blockchain and multi-layered architecture of Internet of Things for safer data transmission procedures. And my presentation consists of few parts: problem definition, state-of-the-art, method, approach, results, and conclusions. Let's start with a few definitions. The Internet of Things is a global network of smart objects with sensors, controllers, software, and capable of gathering, processing, exchanging data, which functioning is based on interaction between currently existing or completely newly developed information and communication technologies. In the context of the Internet of Things, a smart device is the physical or information world object which can be easily identified, authenticated, and connected in the communication network. The physical object exists in the real world, and the requirement data about is obtained through stimulated and connected sensors or controllers, which have communication and share properties with other similar objects, people, or environments. The information object exists in the digital world and has a specific aim, uses a smart interfaces, and has unique attributes, consists of data strings, and can perform the division actions. The number of things connected in the internet is steadily increasing, and they predicted that by 2020 years there will be about 50 billion interacting physical objects. The launching and linking process of the physical objects to the Internet of Things is related to some important problems of their authentication for ensuring safety over the wireless connection. The possibilities of connection to the Internet of Things differ in a broad spectrum of different equipment for functionality of objects, communication protocols, and other things. The communication of objects in the Internet of Things environment is often interfering with some disturbances and safety threats on the wireless and smart condition. In the case, the safety is one of key components of the information system or the Internet of Things, which allow identifying and authenticating smart devices, establish the operation rules, protect transmitted data from eavesdropping, interception, and modification. Let's represent some process in the simple Internet of Things system represented in the second figure. Here, 4 Internet of Things sensors are illustrated where temper sensor detects heat, by how model sense detected temper from the sensor to the control sensor. Control sensor makes decision that command should be sent to the sprinkle based on the previously received temper from the temper sensor. Actuator represents the sprinkle turns and puts out the flame or turns off depending on the commands from the control center. Let's suppose that an attacker, which means to break a normal flow of this Internet of Things system, exploits the weakness of the Wi-Fi connection between the Wi-Fi model and the control center. This way, he gets access to the temper, which going from the sensor. Then attackers change that temper value, and this leads to overheating and consequently is harms miracle. My research study is related to the implementation of safeguard algorithms on the first stage objects identification and authentication before the permission stage for launching in the working area on the Internet of Things. The application domain is related to the requirements for the safety of the multi-layered infrastructure of objects by linking the war Internet of Things. The aim of my research is the evaluate some safety means related to the identification and authentication states of objects by integrating them with the functionality of blockchain. The research objectives are related to the development of more safety working algorithms by representing the stage of checking the identity of the Internet of Things objects. The increasing popularity of the Internet of Things highlight the risk remote control objects that often also have unencrypted remote access that at our side can enforce it by using freely available tools. The Internet of Things object security vulnerabilities are one of the biggest risks, and security vulnerabilities causes the greatest threat of the Internet of Things environment because the manufacturer seeks to increase related cheap objects and the lowered cost, and no much attention is paid to cybersecurity, identification, and notification control of various Internet of Things objects. The reliability of service provided is an important aspect of hardware and software reliability because hardware made even by reliable manufacturers, which assembly on trusted country may pose these vulnerabilities. Due to low computing resources, the object's encryption is also ignored, and this threat is relevant in the international level, where this reason European Union seeks to establish certification for the objects and services. Those are mainly retailed to enable access to services and open ports where users can block this access themselves by exchanging user login data of the control panel and restrict access from the external network. A hacker may look for vulnerabilities in the Internet of Things in order to fully execute and plan a cyber attack when to the active do not require specific knowledge and tools, and public available tools are sufficient. Furthermore, due to the current lack of regulation both in Lithuania and the European Union, users perhaps devices that are not subject to additional safety requirements and devices perhaps have open ports and secure passwords. They do not encrypt a communication, have unsafe architecture and software code. In 2018, the National Cybersecurity Center under the Ministry of National Defense detect 21% more Internet of Things objects vulnerabilities than in 2070 years. The possibility of integration of safety means with blockchain functions can help avoid some types of Internet of Things risks, and research agree that blockchain networks have distinct properties and can be used in various applications. The most frequent and most important advantage of the blockchain are access, availability, accountability, confidence, integrity, privacy. The blockchain network types are divided into open and closed, where public network anyone can publish a transaction and participate in the network by adding to set a publisher rules, and the private network is accessible to those who have permission, and transaction can be edited administration. The blockchain in this administration transaction storage database system where transactions is stored with all members of the network about fund transfers, issuers, loans, and property information. The main advantage in blockchain technology is that it's impossible to modify or falsify records, and each block that records the most recent transaction in the form of digital records connect to the previously recorded block in chronological order, thereby forming a blockchain. Each net block is placed at only the end of circuit and has a fast block diagram where the main aspects of safety of blockchain technology are openness, safety, and decentralization data storage. The blockchain is open only database maintained in a distributed fashion by all nodes in the peer-to-peer network. The peer-to-peer network function implies that there is no complete central control, and all nodes in the peer-to-peer network can communicate with each other using a private protocol and allows for transactions to be exchanged directly among the peers. The blockchain network consists of independent servers that are members of the network, have a copy of the data, and can operate from anywhere of the world by performing some mathematical operation of blockchain function. Where a new transaction arrives, the spreads over the network participant mathematically check the transaction, add it to block depending on the consensus algorithm, perform mathematical calculation to validate the entire data block. The first member sends in the foundation to other after checking of the block, approving it, add to the blockchain, and if there is consensus that adds the number of participants in the block network is considered correct. By implementing decentralization in practice, the IoT system damage is impossible because all computers in the network should be decentralized as long as there is last one running independent computer, the system running. So new computers are connected to the system, expanding and strengthening the network, where a network of participants create each transaction in the system, validates and records in the typical blockchain data. The real-time transaction can usually be tracked in the peer-to-peer network, and each member of the blockchain network can directly see how many in total transactions are made by one participant, but cannot identify in the real life. The data safety and reliability in the blockchain network are based on mathematical calculation algorithms, where the network participant may be restricted from writing and reading access right to an existing network. To falsify records in the blockchain in the Internet of Things, hackers should compromise cryptography so that more than one of the computers on the computer network make the wrong decision and approve the counterfeit transactions. The approach based on the multi-layered structure of identification and authentication of Internet of Things objects by implementing the blockchain technology functions to search, record, and delete data as the black box with the implementation of all side functions in the blockchain. Some types of vertical safety means are analyzed, and the results of using blockchain methods for safety communication described in the level of stepwise algorithm development to ensure safe communication between the IoT objects in the data transferring process. Another critical factor is impact of safety methods, which implemented in the creating of safety techniques for safety Internet of Things by improving structures for more safety mechanisms. Safety should be ensured at all levels of the protocols and middleware. The analysis performed and how the object integration stacks and protocols have to be created to ensure the maximum level of protection and based to the definite guidelines. A method of Internet of Things of objects identification and authentication were developed. The open source systems and tools have selected for the Internet of Things object identification and authentication method, which allows their development prototype to be transferred to cloud or virtualization platforms and use it from the appropriate functionality development. The architecture is modular, supports the possibility of extensibility of the functions and allow adding new specialized servers or containers to the fog layer. The information received during messaging process from the objects is transmitted to the aggregation servers. The use of the representation state transfer application interface servers allows operating to be performed in the blockchain. So new system, the components can use the finished application interface and reference to provide additional functionality of the Internet of Things system. The proposed algorithm of expression of the extended functionality of checking process of object before the connection to the Internet of Things environment is development with the implementation of safety procedures. The identification and authentication process starts when the object initializes the process of data transmission and the data from object transmitted to the fog layer, the wall architecture. There is important identifiers of objects where I is the identifier or equivalent, G is an authenticating index of the object, and K indicates the functionality or status of the object. And the stage of registration, object sends a message to the message broker in the fog layer, which forwards the message for processing. An object identifier I consists at at least four variables is I1 and I2, where I1 variable represent the direction function of object hardware, and I2 variables represent of uses of physical unequivalent function. The fog object receives a message from the object and applies it to blockchain using an API which are accurate to verify the object's identity. The necessary steps is needed in the verification procedure for increasing safety to start work with the connection object in other three procedures responsible for checking, registration, authentication, and safety means conditional object identifier. If those type of conditions are not satisfied, the object removed from the environment and some activities performed to informing about the unsafety conditions of object, which forwarded to the stage of removal of the objects from the Internet of Things environment. The registration procedure is initiated by the object and requires sending in the name and identifier, which is sent to the message broker, while later forwards the registration message for processing. The object identification or authentication occur each time when the object accesses the fog layer, and the data transmission procedures must always transmitted with the object identifier. The object removal process is performed by the block of system administrator functionality in the fog layer server if this action is affected by consensus or satisfaction checking activities. The fog server or administrator function block can refer to the blockchain by using an API records and remove the object from the blockchain. The structures of the blockchain functionality by implementing the authentication method is the fog computing side. The fog server consists of broker function with functions or API message processing server of data aggregation servers. The blockchain platform always operates in the fog layer. The blockchain servers with the fog servers exchange data only through the API service calls. The system architecture designed with scalability and the total number of servers running in the computing farm can be increased to expand the IoT system performance and capabilities. This is necessary to adapt the increasing number of Internet of Things objects and based on the fog layer architecture and components to the of the data transfer protocols have to perform it. After comparing some proposals of existing Internet of Things architecture, compatible objects data communication protocols proposed using MQP protocol, which has higher safety, extensive compatibility, and more scalability capabilities. The possibilities of implementation consensus algorithm in the blockchain communication process proposed by many researchers with the application of mechanisms of working structures. The blockchain network members continuously communicate with each other, synchronize blockchain and new transaction approve blocks and add to them existing chain. By using the popular proof of work consensus algorithm, participants must turn a block with one's value to add a new block to the circuit so that other block header hash is smaller. To use this algorithm, the serverity of the blockchain in the network controlled by the objects currently connected to the network computing power. So even in particular, participants allocates a large amount of computing power to the computation, while all participants also use power to computers. The proof of stake consensus algorithm is based on the number of cryptocurrency participants working on given networks, but not on the amount of computing power. This consensus algorithm was proposed as an alternative to proof of work to make the network more secure and reduce the energy costs required to operate a blockchain network. When designing a new network is decided according to the needs which protocol will be used and what algorithm the network will be based on. The network evolves and expands. The network protocol may need to rewrite or change other required functionality or specific change are required. In this case, hardware performance network operation improved, and after a change is up each member of a network to decide which brand they will support and participate. In the structure of the integration of the Internet of Things objects in the Docker network of blockchain platform, the Hyperledger fabric system used for implementation of operation of the blockchain platform and Hyperledger composer to facilitate the prototyping of blockchain application. The Hyperledger composer used to prepare scripts and create a virtual Hyperledger fabric blockchain system where the Docker builds the multiple initial containers, how peer, dev peer, CodeDB, CA, and order. The peer container performs the process of blockchain operation and consensus mechanisms. The peer container performs blockchain operators that are validated by the peer container by using the consensus protocol. CodeDB database stores data status information and blockchain records. CA containers performs a certificate authority management function, issues private key infrastructure based and certificates to network organization, one root and registration certificate for each authorized system user. Orderer container divides transaction into blocks and distribution server operates independently of the execution servers. The message processing servers are located at a short distance from the Internet of Things objects because they freely access block circuit platforms using API requests depending on the message type and function. The recipe for works on the processing server, blockchain servers, and data aggregation servers perform aggregation and processing functions while terminal access the proxy servers. The RabbitMQ server message broker works only on proxy servers to forward messages to other servers running message handlers. The IoT objects can be mobile devices, so data from them can send to the geographically closest proxy servers. This functionality provided by load balancers or specific canonical name records. The experimental step described by the demonstration of stages of performing the model of information of data transmission and processing in the Internet of Things environment developing. Some models required for development which needful for the secure performing of identification or authentication states of objects by connecting them into the Internet of Things. At the start position, need to safety requirements defined in the first table and the tailored analysis of the safety requirements for the identification and authentication states of smart objects of the Internet of Things became the requirements for developing the information model of the system performing. The model of information of data transmission and processing Internet of Things environment by connecting the smart objects consists of a database, control unit, and smart objects. The database stores various data received from smart objects. The smart objects receive data from sensors and transmit it to the control unit. The control unit collects data from the smart objects, processes, stores, and represents it to the system user. The security management in the data transmission consists of protocols and algorithms for creating and encrypting connection, which performed by exchanging an encrypted private key for communication between smart objects. The Internet of Things information system successfully checks the suitability of smart objects. The requests sent to smart objects that are activated from the control unit to then enable the reading of data from sensors every second. The blocked smart objects are registered in the database, and about this end are reported in graphical user interface. The main commands performed and result obtained on the control unit of the Internet of Things information system shown in the second table. The simulation of the data eavesdropping attack was performed on computer using smart RF protocol packet sniffer software. The security requirements of the Internet of Things information system are implemented data of the smart device read from the control unit, and the data listing system on the computer is activated. The data message activation command 0100 is used to print data packets of the smart RF protocol packet sniffer. The packet number of the found data message activation command is 324, and the traffic packet is 330. The read data is encrypted, which means that the Internet of Things information system is protected from the threats of the eavesdropping and tampering and other attacks. And some conclusion of my research, in the Futura plans, I plan strengthen the security model of the Internet of Things object identification and identification, perform more experiments. And thank you for listening, and conference organized for the opportunity to present my research. Any questions?